Hello, let's solve a problem from K2018 Aerospace Engineering paper question number 47. The question is the boundary layer thickness at the location of a sensor on a flat plate in an incompressible laminar flow of air is required to be restricted to 1 mm for an effective measurement. If the flow velocity is 20 meter per second with 1 bar pressure, 300 K temperature and 1.789 into 10 power minus 5 kg per meter second viscosity, the maximum distance in mm of the sensor location from the leading edge is dash. Right? For an effective measurement of the for the effective measurement of some parameter, the sensor has to be placed on a flat plate from a leading edge. Okay, so we have to find that location where the boundary layer thickness is 1 mm. Right? Let's go and do that. So let's say this is the flat plate that we are interested in studying. So in this, our boundary layer is developing like this. Okay, so we have to find a specific location. Let's say this is our specific location, or x is equal to what? At this, our boundary layer thickness is 1 mm. Right? So what is the parameter that the equation that relates the boundary layer and the distance from the leading edge? So that is the boundary layer thickness formula from laminar incompressible flow of air over a flat plate. Right? So that we will get 5x by root of Reynolds number at x. Right? So what you will get? So the Reynolds number would be given by 5x root of rho u x by mu. Right? So 5, so xx will get cancelled. So then we will get x mu by rho u. Right? So if you square it on the both sides, we will get 25 x mu by rho u is equal to delta. So x would be given by rho u delta by 25 mu. So we have to get our rho from our pressure and temperature that is given, right? So P by R into T infinity, P infinity, right? Our P infinity is 1 bar, which is equal to 10 power 5 Newton per meter square, right? So our temperature T infinity is 300 bar Kelvin, and then our viscosity is 1.789 into 10 power minus 5 kg per meter second. Right? So from this we can just find our rho. So let's just substitute this here. P infinity u del by RT infinity 25 mu infinity. Right? So that's our x. So our P infinity is 10 power 5. Our u velocity is 20 meter per second. Our boundary layer thickness is 1 mm, 10 power minus 3, right? 25 into our R is 287 into our temperature is 300 and our viscosity is 1.78 into 10 power minus 5. Okay, so if we calculate, then we will get 0.052 meter. So if you want to convert this to into mm, then we will get 52 mm. So we have to place our sensor 52 mm from the leading edge of the plate, where our boundary layer thickness is 1 mm, and that is the optimal placement, maximum distance that you can place a sensor to get an effective measurement, right? So the answer is 52 mm. So just we have to be careful that it's been asked in mm, we have to write the answer in mm. right? That's all for this question. If you want to know more about similar concepts, you can refer to the NPTEL course Introduction to Boundary Layers by Professor Rinku Mukherjee from IIT Madras. You can also refer to the week number 3, module number 13 lecture, which is derivation of Prandtl's laminar boundary layer equations. You can also see the YouTube link for the particular lecture here. So that's all for this question. Thank you.